Okay, naming flow chart. Naming flow chart looks like this. We've got the little flow chart. Gotta put the pin on. Okay, so if you're looking at periodic table, remember metalloids, nonmetals, metals, transition metals. All right, so if you're looking at the flow chart, anything that comes down here, say is sodium. If you got sodium plus, I don't know, oxygen. Okay, sodium's the metal, oxygen's the nonmetal. So that's a typical straight up ionic bond. So you look down here, is there a transition metal? No. So you're going to follow this right on down. So that sodium, which is Na, has a +1 charge. Oxygen, which is O, has a -2 charge. Crisscross those charges. Tells us that our formula for this would be that it takes 2 sodiums to balance out every 1 oxygen. So that's going to be sodium oxide. All right, cool. Let me hit. Okay, so let's have a transition metal. So we got iron. So we look at our little thing. We got iron plus oxygen. So is iron a transition metal? Yes. So that means we follow down and we find the oxidation number. Well, I've given you the oxidation number. I've told you iron +3. So that means we go down, we do the same thing. So we're going to have iron, which is +3. We're going to have oxygen, which is a -2. Crisscross those charges, which means we're going to need 2 irons and 3 oxygens. That means 3 times -2 is -6, and 2 times +3 is +6, and +6 and -6 cancel each other out. That gives us our formula, and make sure we got it right. So this is iron, parentheses with the Roman numeral. So iron 3, then we just change the ending to oxide. Okay? That's how you do transition metals for ionic bonds. Okay, so looking over here, and we're looking at nonmetals. So we look at our handy dandy periodic table, wherever the heck I put mine. And we're just going to pick 2 nonmetals. So let's just say sulfur, which is S, and we'll go fluorine, which is F. So we're looking at this now. We don't care about the charges. We're now thinking about what we need to balance each things out. So now we're talking Lewis dot structure. So we're looking at sulfur. Sulfur is in the 16th column, which means just like oxygen, it's got 16 electrons and, or sorry, 6 electrons in its outer shell, which means it still needs 2 more. Fluorine's got 1, so it will share here, which means we need to have another fluorine come in, share here. So when we go to name this, we write the first one first, sulfur. And we got fluorine, which we're going to change to fluoride. Sorry, there's the I. And we got 2 fluorides that are needed. So we look over here and we say that this is sulfur difluoride. All right, and if we had any of these numbers, so say we had anything with the word penta in front of it, then like penta oxide. Well, that would mean whatever we bonded this with, whatever this imaginary element that I didn't name here, that would be whatever that element plus oxygens, 5 of them, so penta oxide. So it's going to give you this little thing here. All right, let's try to pause again if I can find where the little record button went. So if we're trying to name anything and we see 3 elements or more, we're going to look on the polyatomic ion list. Here's an example of one, like nitrate. Here's the charges, so they're going to work where these things right here are covalently bonded. They're sharing electrons. They're just not sharing the right amount, so they still need to go out and ionically bond to something else. So it's kind of a combo bond. So if you had sodium and nitrate, which is given on the chart, so we look up at back up at the chart, we find nitrate, which is a -1 charge. So sodium has a +1 charge. Nitrate, which is NO3, has a -1 charge. So that means when we put them together, and I'm going to write it up here, it's going to be NaNO3. And it's going to be called sodium. We write the metal first always, and then the name of the ion, or the polyatomic ion, which is nitrate. So that'd be sodium nitrate, and that's a pretty decent ingredient in a bunch of fertilizers. All right, we're going to scroll down to the next page here. Okay, so here we're going to go follow the directions. This is the third page on this handout. Maybe the second page, since I think I put the first two together. But here we got barium. Barium's a metal. Chloride's a nonmetal. So that's going to be ionic. Carbon dioxide. Carbon's a nonmetal. Oxygen's a nonmetal. Plus, anytime you see this di, that's a good sign that's covalent. So that's covalent bonding. Magnesium oxide. Metal, nonmetal. Ionic. Aluminum fluoride. Ionic. Nitrogen tribromide. Well, first off, we're seeing the Greek prefixes. So that means there's going to be, this would be nitrogen and 3 bromines. But again, that would be covalent. Chromium fluoride, ionic. Potassium oxide, ionic. We jump over here. Li2O, lithium oxide. We just changed I. Sodium chloride, potassium oxide. This is calcium sulfide. This is, I'm sure I'm misspelling it, beryllium. All right, listen to my periodic table flip. B-R-Y. So that's beryllium iodide. This is aluminum. Bromide. Calcium. Fluoride. Metal, non-metal. So this is magnesium. Oxide. This is lithium. Fluoride. All right, I'm going to hit pause. Okay, so we used a polyatomic ion sheet with a little chart above you to name these. So SO4 with a -2 charge is a sulfate polyatomic ion. O2 with a -2 is a peroxide ion. SO3 -2 is a sulfite. All right, so most of these are ended in ite or ate. So notice these two, the only difference in them is this one has 3 oxygens, this one has 4 oxygens. So NO3 with a -1 is a nitrate ion. This is ammonium. Not being confused with ammonia, which is stuff that's in the Windex, which would be NH3. This is chromate. This is hydroxide. PO4 is phosphate. And this last one is carbonate. This thing seems to be slowing down on me. Okay, continuing on in the sheet, we put what these Greek prefixes mean. So penta is 5, nona 9, mono 1, octa 8, tri of course is 3, tetra would be 4, hepta is 7, so hexa is 6, deca is 10, and di is 2. We look over here. Carbon monoxide is number 4, so that would crisscross to there. Carbon dioxide is number 1. Dicarbon monoxide is 5 here. Dicarbon pentaoxide is number 3. Dicarbon tetraoxide is number 2. And carbon, well, obviously, it's the last one, which is 6. All right, so jump in here. This has 3 oxygens, so that is tri. This has 3 nitrogens, so that is trinitrogen tetrachloride. This is sulfur, 2 of them, so sulfur dioxide. That's the stuff that makes acid rain. Phosphorus penta oxide, and this is disulfur tetrafluoride. All right, last section on this. Calcium CaSO4 is calcium sulfate. This is potassium. We do not need the di in front of it because potassium is a metal, so this is ionic bonded. Same here, copper and NO3. NO3 is nitrate or nitrite. Let me look it up real fast. Nitrate. This is ammonium chloride. This is magnesium and NO3 again. So this is magnesium nitrate, and we do not need a dinitrate. This is figured out by the fact that you know that magnesium has a +2 charge. This potassium PO4 phosphate. This is lithium chromate. This is magnesium hydroxide. It's supposed to be a D. This is aluminum. And PO4, I'm quite certain, phosphate. Potassium. Nitrate. Calcium. And this is still SO3, so SO4 is sulfate, so this is sulfite. I'll look it up. Yep. Okay, so we go over here. We again name it and identify it. So carbon and oxygen, that's covalent. That's carbon. We only have one oxygen, so monoxide. We got silver, and we have oxygen. Silver is a transition metal, so this is ionic, but the silver is going to need a number. So to figure out that number, we look at oxygen. Oxygen has a -2 charge. So if we need 2 silvers to balance out 1 oxygen, that means that the silver's charge has to be a +1. So we got silver 1 oxide. Here we got potassium sulfate, which is polyatomic. I don't know why my pen's dragging so far behind. Potassium, and I said SO4 is sulfate. All right, the next one is magnesium bromide, and that's ionic. This one is SO3, which is should be a polyatomic ion. That should have a, but it's not because it didn't give us a charge, so we're just going to call this covalently bonded. And if we were to name this, this would be sulfur trioxide. This would be covalent. This would be polyatomic. This would be ionic. This would be covalent. This would be covalent. Let me pause this for a second and let the memory try to catch up. Just say these out loud, and then I'll write it down on a piece of paper and scan it and send you the answers for this, so maybe you can read it better. So this one was sulfur trioxide. This one would be diphosphorus tetraoxide. This is polyatomic, so this is beryllium chromate. This is lithium fluoride. It's ionically bonded. Covalently bonded, this is carbon dioxide. And of course, this is oxygen and fluorine combined, so it's covalent. There's 2 fluorines, so this is oxygen difluoride. All right, and that's more than enough time on this thing.